Alright, ladies and gentlemen, today we're going to be working on section 9-3, which is a linear functions review. You should know most of this stuff already back from chapter 8. We're just going to start working on it again to make sure that you can keep up with what we've been doing, add in some of the things we've been doing with scatter plots and data, and start to apply some of these functions to the real life. So I'm going to give you a couple of definitions. You already know these definitions, but I want you to write them down anyway. The first one is a linear function. So a linear function is a function that makes a line on a graph. So it's a function that makes a line on a graph. And if I wanted to, I could have said a straight line on a graph, and we know that that's the same thing. We know the general formula for a linear function too, y equals mx plus b, where the m stands for slope and the b stands for the y-intercept. So for our purposes, that's what you need to know about a linear function today. The newer vocab on here is called function notation. Function notation is a way for people to differentiate between different functions. If we had a bunch of equations and they all started with y equals, it would be hard to say, oh, it's that y equals function or this y equals function. So function notation was invented to let us keep our functions straight by using different letters. So in function notation, you will see things written as f of x. So fx in parentheses is pronounced like f of x, and f of x is the same thing as y equals. So y equals and f of x equals mean the same. Alright, you could also see things with different letters, so g of x or h of x. And the reason for that is so we can keep different functions straight if we have more than one function. So function notation, all you really need to know, every time you see f of x, you could replace it with y equals, and that would be exactly the same. Our first example down here is to determine whether functions are linear. So now remember that linear functions must be able to be written in y equals mx plus b form. So if we take a look at our first function here, we've got f of x equals negative 2x cubed. Well, we know f of x is the same thing as y equals. We can rewrite this as y equals negative 2x cubed. And now we ask ourselves, is this a function that can be written as y equals mx plus b? Well, in this case, we have this exponent right there. And because this function has an exponent, there's no way we can get rid of it. It could never just be written as y equals mx with no exponent. So this is not a linear function, and that's because of the exponent. Alright. If we move our paper over, I'll try and make it so you can see both of these. Let's see. No, because it's not an exponent. So over here, we've got another function, f of x equals negative 2x plus 4 plus x. So once again, we know we can change our f of x to say y equals. We've got negative 2x plus 4 plus x. So what I notice right away here is that I have 3 terms instead of 2, and I need to be able to only have 2 terms because I'm writing this in a y equals mx plus b form. So I look through my terms and I say, well, which ones can I combine? Are there any like terms here that can be combined? And I see that this term and this term both have x's in them, which means they're like terms and I can put them together. So I have a negative 2x and I have a 1x. Remember, we can put the 1 in front of the x if we have no number in front of it. So I've got really negative 2 plus 1x, and negative 2 plus 1 gives me negative 1x. Then I bring down my plus 4 because I can't do anything else with that, and I've got y equals negative 1x plus 4. Now I compare that to my y equals mx plus b, and I look up here, and y equals mx plus b, y equals negative 1x plus 4, they match right up. We've got a slope, we've got a y-intercept, so yes, this is a linear function because it can be written as y equals mx plus b. So written as y equals mx plus b. Make sure you can see that there. So that is indeed a linear function. So all you have to do for those is decide whether you can write them in y equals mx plus b form. Let's move on down here to write equations for linear functions. We've done this before. We've done both of these types with a graph and with a table before, but I want to walk you through some examples just to refresh your memory. So we're writing an equation in function notation for each of the following functions. So instead of writing an equation that starts with y equals, we want our equation to be f of x equals, all right? We'll do both so you can see that they're both exactly the same. So remember that in our functions, the m, the first letter in y equals mx plus b, stands for slope, all right? So we're going to find the slope of this graph. We know how to do that. We're going to take 2 points on the graph, and we're going to make a stair step in between them. And your stair step, again, it can go above like this, or it can go underneath if you want it to. And we're going to calculate our rise and our run. So the rise here is going to be 2. We go up 2 boxes. The run is going to be 1. We go over 1. So in my slope, I'm going to use rise over run, which is 2 over 1 in this case. And 2 divided by 1 just gives me 2. So when I start to write my equation, we've got y equals 2x because my slope is 2. So y equals 2x, or f of x equals 2x. Then we just need to talk about the y-intercept. And once again, the y-intercept is just the spot where your graph crosses the y-axis. So right there is our y-intercept. Our y-intercept happens to be at a positive 2. So we're going to write plus 2 as our y-intercept. So our function is y equals 2x plus 2. Or because they wanted it in function notation, it's f of x equals 2x plus 2. Let's take a look at our table here. We've worked with tables again before. We've been able to find the slope and the y-intercept from tables. So if you take a look at this table, we're going to take a couple of those points and we're going to rewrite them as coordinate points. And I'm going to use the positive number coordinates just so that I have positive numbers to work with instead of negatives. So I'm going to use the coordinate point 1, 4, and I'm also going to use the coordinate point 3, 10. So to find my slope, which is the first thing I want to find, I have to use the slope formula. The slope formula, you remember, is y2 minus y1 over x2 minus x1. So that gives us a spot to put all of our information in. So we're going to fill in that formula with the information that we do know. Draw your fraction line. And we've got y2. So our y2 number is going to be 10 because that's our second y-coordinate, minus y1. So we're going to say minus our first y-coordinate, y1, which happens to be 4. Then underneath of this, we've got x2 minus x1. So my x2 is going to be 3, minus my x1, which is 1, my first x-coordinate. Then we solve to find our slope. 10 minus 4 is 6. 3 minus 1 is 2. So we end up with 6 over 2, or 6 divided by 2, which gives me a slope of 3. I can start using that in my function. I can start making my function y equals 3x, or f of x equals 3x. And then I have to add my y-intercept. So if you remember from when we were making our road trip projects, we can add our y-intercept as an adjustment. So if we were to put one of our inputs into this function as it stands right now, we would be able to see how we need to adjust it. So let's try that. Let's use this point right here, 1, 4. So in 1, 4, if I'm going to take a 1 and I'm going to put it into my function, y equals 3x, I'm going to say y equals 3 times 1, and I get a 3 out of that. But I know I shouldn't get a 3. I know I should get a 4. So I think, how do I adjust to get from a 3 to a 4? Well, I could add 1, and that seems like it would work. I'm going to try one more point to make sure. I'll try the point 3, 10. So I'm going to say y equals 3 times 3, since we have y equals 3x for our slope, and then the 3 from the point 3, 10. 3 times 3 is 9, but I need it to be 10. So my pattern continues where I would need to add 1 to get from 3 to 4 or 1 to get from 9 to 10. So I know that my y-intercept is 1. My final function is f of x equals 3x plus 1. Alright, same thing as y equals 3x plus 1. We just write it with an f of x in the front instead. Let me move this over for you. Here is another graph that we're going to find the equation for. So when we find the equation for a graph, first we find our slope, then we find our y-intercept. And again, we're going to use rise over run to make our slope, so let's pick 2 good points. Here's a point that crosses directly at a cross mark on our graph. This one doesn't work, this one doesn't work, this one doesn't work, but this point also crosses directly at a cross mark. So I'll use those 2 points. I'll make myself a nice stair step here. And then I'm going to count my boxes. So my rise is 1, because it goes up 1. My run is 1, 2, 3, 4, so my run's going to be 4. And if I wanted to do that as a rise over run, I'm going to make that into 1, which is my rise, over 4. So there's my slope. 1 over 4 is a fraction of just 1/4. When I start to write my equations, I'm going to write y equals 1/4 x, or I'm going to write f of x equals 1/4 x. Then after that, I'm going to find my y-intercept. On a graph, that's pretty easy because once again, it's the point where my graph crosses the y-axis. My graph happens to cross the y-axis at 1. Right, 0, 1, 2, there's my 1. So I'm going to say plus 1 as my starting point, as the point where my graph crosses the y-axis. So there's my function, f of x equals 1/4 x plus 1. Give you a second to copy all that down. Alright, let's move on to some real-world problems, and we're going to see a lot more of these in the near future. So I'm going to read through this problem, and I'm going to kind of highlight or underline the important information that looks like it could be useful in our answer. So it says a video club costs $15 to join. So I see a number, and I bet that that's probably pretty important, so I'm going to underline that. Each video that is rented costs $1.50. So I'm going to underline $1.50, and I'm also going to underline this word, or put a box around this word, each, because that's going to give me some information about which of those numbers is my y-intercept, and which of those numbers is my slope. Find a rule for the linear function that describes the total cost of renting videos as a member of the club, and find the total cost of renting 12 videos. So there's 2 parts there. The first part is to find a rule, and the second part is to find the total cost of renting 12 videos. So when it says find a rule in the first part, what that's asking us to do is that's just asking us to make an equation. We can make an equation very easily out of these 2 numbers because we know we've got y equals mx plus b, or f of x equals mx plus b. In this case, I'm going to use f of x, since it's new for today, equals mx plus b. So I ask myself, which of those numbers is the slope? And in this case, the word each is what clues me in that $1.50 is the slope, because each video that I rent, or each time that I rent a video, I have to continue paying $1.50 each time. Whereas $15 only happens one time. That's my startup fee. That's my beginning. All right, that's my starting point. So that we put as our y-intercept. There's my function, easy as that. F of x equals $1.50x plus 15. So now we're going to use part 2, find the total cost of renting 12 videos. Not difficult. All we need to really do here is we need to take 12 videos and we need to plug that into our function for x. So $1.50 per video times 12 videos. Let's write that out. F of x equals $1.50 per video times 12. I always put my inserted number in parentheses so that I know that's why that's in there instead of my x value, plus 15. So we've got f of x equals $1.50 times 12 plus 15. So we can rewrite our f of x. $1.50 times 12 is going to give me 18. So we've got 18 plus 15, and we add those together. F of x equals 33. So now our question asks us to find the total cost. So we know that cost is measured in a certain type of unit, and we know that unit is dollars and cents. So instead of just writing f of x equals 33, we're going to make our answer $33. Alright, so this is the answer I want you to have on your paper. This gives us the number, and it also gives us the units. Alright, I'll give you a second to finish writing that down. Alright, let's turn this over. Here is the last real-world application problem. A book club. This one looks a lot like the last one. A book club has a membership fee of $20, so when you get to that book club, you've got to pay $20. Each book purchased, there's our keyword each again. Each book purchased costs $2. Find the rule, again, write an equation, for the linear function that describes the total cost of buying books as a member of the club, and find the total cost of buying 10 books. So there's our first part, we're going to find our linear function, and the second part, we're going to find the total cost of buying 10 books. So here we've got y equals, or f of x equals. We use our slope, and we see that our slope happens with our each word again. So each book costs $2, we're going to say 2x, because that is the amount we pay every time we need to buy a new book. And then we're going to say our y-intercept is 20, because we have to say plus 20 there. We pay that membership fee one time, so it is going to be plus 20 as our startup, as our y-intercept, or a starting point. Alright, so there's our first part of the equation, or first part of the problem, done. We're going to work on the second part, find the total cost of buying 10 books. Again, you probably know how to do this already. We're going to take f of x equals, and we're going to just plug the number 10 into our x value. So 2 times 10 plus 20, and we've got f of x equals 2 times 10 is 20, plus that $20 startup fee. So we've got f of x equals 20 plus 20. We know 20 plus 20 is 40, so f of x equals 40. Now once again, don't just write f of x equals 40 as the answer, because that number has units with it. So find the total cost of buying 10 books. So our cost is going to be measured in dollars. So instead of just saying f of x equals 40, we're going to call that $40. Alright, your practice problems for this notes section come from each of the examples. These first two come from that first set of examples. The next four come from the middle set of examples. And the last one comes from the real-world applications. So if you have any questions, let me know, and I would be happy to answer them. Thank you.